Okay, now we talk about question 9. A particle P moves in a straight line with constant velocity. Initially, P is at the point A with position vector 2i minus j. We try to graph. So 2i minus j in here, that's ai. That's displacement meter relative to a fixed point or region O. Okay. And 2 seconds later, it is at the point B with the position vector 6i plus j. So it means 2 seconds. It moved to 1, 3, 4, 5, 6, 6, 1. That's B. Six I plus 1j meter, right here. So find the velocity of P. So we can find what's AB? AB is called displacement vector, right? So displacement still equal to AB equal to OB minus OA. So equal to OB vector should be 6i plus 1j minus 2i minus 1j. So I get AB vector will be 4i 1 plus 1 plus 2j. That's called displacement, right? AB is displacement vector meter. And what is the velocity vector? Velocity will be what? Velocity still equal to displacement over time. So he said 2 seconds, right? 2 seconds from A move to B. So just equal to 4i plus 2j over 2. So become 2i plus 1j meter per second. Okay. This is a displacement vector. Okay, B, find meter degrees, m degrees to 1 decimal place, the size of the angle between the direction of motion of P and the vector of I. So you mean you need to find four I plus 2j, right? In the motion is the motion. Motion is displacement. So 1, 2, 3, 4. You find this angle. And here is 4, here's 2, right? 4i plus 2j. So we get tangent theta equal to 2 over 4. Theta equal to tangent inverse 2 over 4. So equal to, let's calculate. (26) 1 digit decimal 0.6 degree. Okay. See, 3 seconds after it passed B, the particle P reaches the point C. Find in meter to 1 decimal place the distance OC. Okay, be careful here. This is talking about origin to -1A here. You move to 6, 1, B here, right? Here you run a 2 second. So because it is straight motion, he says 3 seconds after. So 1, 2, 3. I think you move to here, the point C. So how do we find C? You just OP, right? The position vector, A of this vector, right? So how do you find the BC vector? So BC motion vector will be velocity times time, right? You can still use velocity vector times time. So equal to 2i plus 1j times 3. So becomes 6i plus 3j. Okay, it doesn't matter C is 6i plus 3j. That's a BC vector. This vector equals 6i plus 3j. So how do we find a C point? That's why I always say you need to make sure you understand point and position vector. Students sometimes always in a detail always confused with point and position vector. BC is a position vector 6i plus 3j. Oh, but sorry, BC is a vector, it's not position vector. But now we need to find OC. We need to find OC. You need to find OC. You need to find C position vector. You can find a C, right? You can find a point C, okay? BC. So you remember, you already know BC, so OC. How do we find OC minus OB equal to BC, right? BC equal to OC minus OB, so equals 6i plus 3j. Now we want to find OC, right? Therefore OC equal to 6i plus 3j plus OB vector, right? So equal to 6i plus 3j plus OB vector, B vector, OB should be 6i plus j, okay, plus 6i plus 1j, so equal to 12i plus 4j. So we get the OC vector is 12i plus 4j, therefore OC length will equal to square root 12 square plus 4 square, so equals square root 160 equal to 4 square root 10, okay?